Hey everyone, thanks for being here today. I'm Cory, and I'm going to speak to you about one of the most difficult decarbonization challenges our world faces. So cement production accounts for 7 to 8% of global carbon emissions. And if global cement manufacturing were a country, it would be the third largest emitter, only behind China and the United States. Cement decarbonization is imperative for new sustainable construction of our building stock and infrastructure because we simply cannot stop using this material. To avoid confusion, let me state one definition up front. Cement is the binding material that affects the strength, durability, and other performance properties of concrete. Concrete is a structural material, which is the most consumed human-made product. Within 1 cubic meter of concrete, more than 80% of the emissions come from cement production. And all projections point towards increasing usage over the next 30 years as emerging market countries build out their infrastructure. 85% of cement's carbon emissions come from the limestone calcination process and high-temperature fossil heat sources. These emissions occur when limestone, which is the primary input for cement production, is baked up to 1450 C in a kiln that is almost always fired by coal or natural gas. Limestone, unfortunately, emits CO2 when it is baked in that kiln due to its chemical composition. My belief is that our world needs various options to address cement's carbon problem. And last summer, I worked with a company that has the potential to decarbonize cement production. Sublime Systems is a Series A company that originally spun out of an MIT lab, and they're developing and commercializing an electrochemical approach to cement production that eliminates the need for that high-temperature limestone calcination. There are numerous approaches to cement decarbonization that I reviewed for this capstone. Sublime is just one approach. However, there are only 2 pathways that can achieve greater than 50% decarbonization. One pathway is carbon capture and sequestration, and the other pathway is defined as alternative production methods, such as Sublime's technology. So for my capstone, I wanted to examine the potential for Sublime to expand internationally and compete with carbon capture as a long-term solution to cement decarbonization. My problem statement emphasizes the reason why international expansion matters deeply for Sublime or any other low-carbon cement technology. I attacked this problem statement by looking at the techno-economic, environmental, and business factors to produce a comparative siting matrix and phased international expansion plan focused on 2 distinct regions to compare the viability of Sublime's technology in an emerging market context, represented by Brazil, versus a group of more economically developed countries, represented by the European Union. This is the central question that has guided my research over the past few months. How would a company like Sublime achieve international expansion in the next 10 to 15 years? I started first by analyzing the regulatory risks and opportunities in each region. It's clear that European cement producers are feeling an existential pressure to decarbonize, and this is because of a few reasons. First, the EU emissions trading system will begin to phase out free allowances for cement producers in 2026. This is going to force producers to adopt decarbonization technologies. Also, the EU recently adopted a new policy package which effectively doubled the linear reduction factor. This means a lower total CO2 emissions cap, less available allowances, and higher CO2 allowance prices. So this leaves cement multinationals heavily reliant on carbon capture and sequestration to be able to economically compete within the European cement market as the financial pressures from the emissions trading system ratchet up over the next 10 years. This opens an opportunity for other cement decarbonization technologies to compete. So I built a model designed to emphasize the financial impacts of European emissions policy on a reference Sublime cement plant constructed in the latter half of this decade. I found that the financial impacts for a 90% decarbonized plant would be substantial. The plant would receive up to 110 million euros per year in CO2 allowances sales, which represented up to 30% of total revenue from the facility. The financial value for Sublime is clear, but there unfortunately is no equivalent to the emissions trading system in Brazil, nor is there any type of carbon pricing that the government is looking to place on cement production anytime in the near future. So I investigated other regulatory instruments that have the potential to support low-carbon cement technology as they scale. These instruments fall into 2 broad categories: supply push and demand pull for low-carbon cement. Almost all of these instruments are public sector-led and financed. Only advanced market commitments are a substantial private sector instrument to be able to catalyze the low-carbon cement market. I then examined which regulatory instruments would be available to Sublime in the European Union and Brazil. And unsurprisingly, due to the fiscal burden that these instruments impose on the government, the EU dominated Brazil across nearly all of the categories. We won't have time to review each of the instruments in detail or their relative effectiveness, but I'd be happy to answer your questions during the Q&A. So, while it became clear to me that the regulatory opportunities and market demand were promising for Sublime in Europe, the situation was much murkier in Brazil. So I had multiple interviews with Brazilian industrial executives where I learned 3 key points. First, there is a very low tolerance for a premium on cement, and so customers are by and large not asking for any green cement, with the exception of large international customers like Amazon. Secondly, Brazilian cement producers are focusing their sustainability strategy on maximizing the existing levers first, such as switching to biofuels to power their cement kilns. However, there was one opportunity. There is a lack of political will for a carbon capture and sequestration build-out in Brazil. I believe this could lead to a long-run opportunity for cost-effective alternative production methods to leapfrog over carbon capture, as Sublime's technology would not be reliant on the public infrastructure build-out that is required for carbon capture in these emerging markets. Beyond the regulatory and market demand factors, low-cost renewable energy is critical for Sublime's facilities. This led me to my next phase of analysis, where I explored the availability and cost of clean power in various regions of Brazil and Europe. I evaluated 3 energy procurement approaches to identify regions best suited for Sublime. The strategy to identify regions differed for each approach. For behind the meter, I analyzed levelized cost of energy forecasts. For grid purchasing, I identified the already clean grids and evaluated industrial electricity prices. And for the PPA approach, it was a combination of the prior 2. While we don't have time to go into the details of the analysis, the results identified a few similar regions across energy procurement approaches. With the direct connection approach, the most favorable LCOE projections for combined wind and solar are in Spain and the northeast region of Brazil. For the clean grid purchasing approach, the Nordic countries and Iceland offer cheap decarbonized power relative to the rest of Europe, while in Brazil, the south region has massive hydro capacity and, again, relatively cheap industrial power. Ultimately, I believe the pathway to international growth runs through the European Union with an initial facility sited in a Nordic country or Spain. The impacts of the ETS on cement production and the available regulatory instruments are too advantageous to pass up. So after Sublime builds their first commercial facility in the United States to demonstrate the technology, there should be an open door to Europe. It will be important to work with one of the European cement majors to be able to access the distribution infrastructure within the continent. And once the technology has been proven at the megaton scale, Brazilian executives indicated their interest in partnering to bring the technology to South America. The hope is that by 2035, there is a clear opportunity to license this technology in various emerging markets around the world. This phased expansion would enable Sublime to play a major part in solving cement's global carbon emissions problem. Thanks so much.
Thank you, Cory. Help me think about, you mentioned the demand for cement in emerging countries. So how does that tie in with the fact that you want to go to EU first? Is cement something that you can easily transport to emerging markets that may be the growth areas for that demand? Or how do you think about where cement is actually needed versus where the markets are best suited to have a plant?
I think I understand. So generally, the trend is that the demand will be increasing for cement across basically all of the emerging markets around the world, whereas in China, India, and the EU and North America, the demand is pretty flat or receding. So it's not necessarily, while plants get retired, there will need to be new capacity built. And in a region like the EU, where there will be actual decarbonization pressures because of economic policy, there will be a near-term opportunity. However, I think the goal is that if you're able to develop a cost-effective technology, then the plants should always be sited in the next 10 to 15 years in that developing part of the world where they're going to need more and more cement capacity. You can, and there is some trade of cement internationally, but it is largely a locally produced and consumed good.
I'm super curious how, when you look at the timeline for EU expansion, Brazil expansion, or any other, what is the optimal size plant to build for both speed of execution and then also capturing those either regulatory tailwinds or things like that? Like how do you scale this from a plant size and scale perspective?
For sure. So Sublime is building an initial facility which is not at what you would say the scale to be able to capture the economies of scale that cement producers enjoy from their existing facilities, which are anywhere from 1.5 to over 3 million tons of cement produced per year. So when it comes to actually building commercially relevant facilities, you have to build them at that scale. So probably 1.5 million tons of cement produced per year or greater, unless you're able to find really unique opportunities for super low cost power or feedstock in specific regions that might allow you to build a smaller facility.
Thank you, Cory. You focused on the EU and Brazil. I'm curious how this framework or any other research can apply to maybe other regions as you look at other opportunities for expansion for Sublime.
Yeah, so my hope was that through picking these two regions, while of course not everything can be translated across, I do think that a lot of the lessons learned from the Brazil in this emerging market context could be applied to other growth markets or emerging markets because of the similarities in the regulatory environment as applied to cement decarbonization. So I think that there's a lot of applicability to take that. Additionally, the energy procurement approach would be, and the analysis behind that is largely can be translated to different regions of the world. So I would hope to be able to bring this and keep extending it to other places as relevant.